u equals x squared plus 6x. Sorry, pen is dying. Giving me du equals 2x plus 6. So let's switch back to black here. Dx equals du over 2x plus 6. Okay, so now back to my integral. I wish I didn't write so big. I'm going to start up here at the top. The integral x plus 3 over u squared. And then I'm going to substitute in dx, giving me du over 2x. 2x plus 6. So I can't really cancel anything out. Maybe. What do I see? I've got 2 x's, and I've got 6. I've got 1x, and I've got 3. I'm going to pull out a 2 from my denominator here, giving me 2 times x plus 3. Well, now I can go ahead and cancel. I have this 2. It's now a constant. I'm going to throw it outside the integral. So the next thing we have is 1/2 integral 1 over u squared. All right. So now I'm going to go ahead and apply our standard power rule. Actually, I'm going to rewrite this here over to the side. U to the negative 2 du. They're equivalent. So I'm going to evaluate that down here. U minus 2 plus 1 over negative 2 plus 1. Giving me, sorry, arithmetic errors there. So I'm going to make sure that I keep this 1/2 in front. Times, I'm going to go ahead and move this to the front, but we get negative 1 plus 1 giving me what? Negative 1. Times u, and then again I get negative 2 plus 1, giving me negative 1. All right, and then I don't want negative powers in my answer, so I'm going to multiply 1 times negative 1/2, negative 1 times 1/2, negative 1 times 1/2, giving me negative 1/2. Over u plus c. The last step is just to substitute in my u. Ooh, not 6. There we go. So I just wanted to make a quick little comment about this question, because I'm sure some of you guys would ask. Do I have any tips for what my u should be? And the short answer is no. The long answer is I would recommend trial and error. There's a good chance it will never be this. It will never be this. It will never be a numerator. There's a good chance. There's always a good chance. In my couple of years of real calculus experience, I have yet to come across a u in my numerator. But I'm not to say that it couldn't happen. Most of the time, it's going to be in your denominator, right? The best thing I can tell you is trial and error. You'll see pretty much immediately you've chosen the wrong u. So let's say, for example, I chose to use u equals x squared plus 6x squared. du. Applying the chain rule gives me 2x squared plus 6x times the derivative here. 2x plus 6. Right? I'm going to multiply that to the 2x and the 6, giving me, actually, I'm going to distribute my 2. Right, anyways, I'll stop right here. There's a good chance you're not going to have to use this. Right? And there's a good chance you're not going to be able to do anything with this once you get this polynomial in terms of dx, or right, you'll have dx here. So then you're going to have dx equals du over this polynomial. Right? There's a good chance you've made a mistake. So the good thing about u substitution is you'll know pretty early on. The bad thing is it's a bit of a trial and error process. So never fear being wrong. That's the point. That's why you guys are here. You guys are still early calculus students. Make the mistakes now so that when you get into your engineering or your computer science or your math classes or your physics classes later, and you're asked to do these things, you'll be more confident. The name of the game is practice for calculus. Practice, practice, practice. As many problems as you can. Do the same problem if you need to. And keep yourself organized. So I'm going to stop this one here.